Hi, I'm Ramon with the Multi.io research team. So our focus here is to go over Ethereum 2.0 and its staking components from a way that non-technical people can understand. There's many misconceptions and confusions around Ethereum 2.0 and its staking upgrade, so I will try my best to clear these up. So what is Ethereum 2.0? Ethereum 2.0 is a blockchain upgrade. The upgrade combines many new technologies that have been under research since 2014 by the Ethereum Foundation and and the whole development community. And it's being released in multiple phases, with each of these phases introducing one of the major technology components. And phase zero is all about staking. So staking is the consensus model change to create blocks and verify transactions by staking capital instead of mining. Phase one is all about sharding. Sharding is a layer one scaling solution that splits a blockchain like Ethereum into many smaller blockchains called shards. And phase two is all about e-WebAssembly. So e-WebAssembly is a redesign of Ethereum smart contract execution layer. And let's explore the Ethereum 2.0 roadmap to get more details on each of these phases. So today, Ethereum 2.0 is in it's in the beacon chain phase with a successful testnet of over 29,000 validators joining the network. And what is the beacon chain? So the beacon chain is the staking layer of Ethereum 2.0. It's a network of nodes that coordinates with the thousands of validator clients that are used to each reach consensus in the individual shards that will later be implemented. So Ethereum 1.0 is being worked on. It's still being worked on with the main goal being future compatible with the Ethereum 2.0 blockchain. And one of the misconceptions is that there's a chance Ethereum 1.0 will not be compatible with Ethereum 2.0. But this is not true. The reason is that this is why they're developing in phases to ensure that every major milestone is compatible with Ethereum 1.0. So phase one is scheduled to start the development process at the end of 2020, where the Ethereum 1.0 integration becomes critical. Here's where we will see the integration of Ethereum 1.0 as an individual shard into the Ethereum 2.0 blockchain. So phase two, this is the final phase that introduces a state execution layer of Ethereum. This brings a new programming language called Ethereum WebAssembly that is being developed to be compatible with Solidity, C, C++, Rust, and Go. So, this can be more attractive to more developers and also keep all the Solidity contracts working just fine on Ethereum 2.0. All right, so let's look at proof of stake versus proof of work. The main argument is that proof of stake allows for faster consensus, and proof of stake is necessary for sharding to be effective because proof of stake allows for thousands of validators to be divided into the subcommittees that are needed to verify the blocks in the different shards. And this is something that's not possible in proof of work because of the slow process in reaching consensus. The debate for the most secure consensus is still ongoing, but many of the arguments I've seen are based on hypotheses of thousands of nodes colluding because of the cost of staking capital is less than that of buying mining equipment. But for a system like Ethereum that's had a real cost in the market with enough independent owners by now, staking capital does have a real cost now. When we compare this to the proof of stake chains that are on mainnet now, like Tezos and Cosmos, where they basically have they have seen no threats to their security models from colluding nodes. And when we compare that to Ethereum Classic, that has suffered a 51% attack recently, while these smaller cap blockchains with proof of stake have not even raised flags for possible attacks. This also brings the fact that mining pools can also make proof of work very unsecure as well. The power to rent hash power is actually very cheap now. for a lot of these high market cap coins. For example, you can rent enough hash power to attack Litecoin for $17,000, Bitcoin Cash for $9,000, and Ethereum Classic for only $6,000. So that's how much it takes for you to rent enough hash power to perform a 51% attack. So let's look at the Ethereum 1.0 versus Ethereum 2.0 tokens. And this is where the misconception comes of a possible hard fork between the two Ethereums because of the confusion that this creates. And basically, the beacon chain will require real Ethereum to be staked in order to reach a real consensus and secure real blocks to prepare for the migration. And once this Ethereum 1.0 tokens are moved to the beacon chain, they will not be able to be moved back to Ethereum 1.0. Basically, validators that choose to stake Ethereum on the beacon chain will start receiving staking rewards, but there will be no transactions on this beacon chain, and no one can build on top of the beacon chain. So there's absolutely no competing with Ethereum 1.0 blockchain because the beacon chain needs Ethereum 1.0 in order to continue. Okay, so let's look at the community support for Ethereum 2.0. And in the Ethereum community, the public debate around Ethereum 2.0 and staking specifically has been very supportive. We're now seeing more of Ethereum's original use cases like decentralized exchanges and stablecoin transfers becoming a big part of the network usage. Therefore, it's understood that scaling needs to come quick in order for these use cases to keep growing. And we'll explore the strong community support. Now, it's hard to make a conclusion from social media on what people are thinking, but when the community is against something, there is a strong rally around that message. I myself have not seen or have not been able to find any strong support for people against Ethereum 2.0. We can compare this to the recent Zcash block reward changes that raised a very strong negative press. And there was it was a clear fact that many in that community strongly disagreed with those changes, and we're just not seeing that here with Ethereum 2.0. And most importantly, the teams building on top of Ethereum have strong support for Ethereum 2.0, especially the bigger DeFi apps like MakerDAO, Compound, Uniswap, and Kyber have all mentioned support for Ethereum 2.0. Let's look at the open finance boom. Now, everyone in the blockchain community understands that in order for Ethereum to keep its dominance in the smart contract world, the network must scale. And we've seen the growth and adoption of many of these original use cases described in the Ethereum white paper gain massive traction this year. And Ethereum has an absolute dominance on decentralized exchanges, on the money market lending apps, and on the issuance of trusted stablecoins and gold-backed tokens. And another reason Ethereum has to scale is because these new blockchains that are being launched every month are going head-to-head with Ethereum, trying to capture the market share of these applications that I just described. And many of these blockchains are very well funded. Some even have some new technologies that deserve its merit. So Ethereum's only competitive advantage is the network effect that it has created. And in order to keep that network effect growing, everyone in the community understands that Ethereum must scale. And a little history on Ethereum. One of the biggest reasons that the community supports Ethereum 2.0 and its staking consensus change is because the change was always in the roadmap. We can see that even before the Ethereum ICO, Vitalik and other members of the core team were in favor of a different consensus model that would better serve Ethereum's use case. But in 2014, there was just not enough research done on proof of stake. Today, we see new proof of stake blockchains being launched every month, and one can argue that a lot of these proof of stake blockchains are are a lot more secure than Ethereum Classic. Now let's look at Ethereum 2.0 staking versus other proof of stake chains. So there's many different versions of proof of stake, but 3 are the most popular right now. We have delegated proof of stake, liquid proof of stake, and bonded proof of stake. Over the years, we've seen proof of stake blockchains raise 30 to 300 times more money than the original Ethereum ICO. EOS raised $4 billion to build their delegated proof of stake consensus protocol. And DPoS works like an election system in which a fixed number of block producers are authorized to secure the network and vote on the blocks. And EOS token holders are the ones that get to vote on who will validate the transactions on the network, with their voting power determined by the size of their holdings. Tezos raised $232 million to build their liquid proof of stake consensus model. And liquid proof of stake allows holders of the Tezos tokens to delegate their stake to bakers. And bakers are the block producers in the Tezos ecosystem. The bakers can join the network at any time and gather support from the community to get more delegators. And these delegators increase their chances of being awarded the opportunity to mine the next block. This is different from EOS, where once the block producers voted in, a new person can't just join in like in Tezos. That's why Tezos is liquid. And in Tezos, if the validator misbehaves, the stake of the baker is penalized, but the delegated stake is always safe. And this brings us to the third proof of stake blockchain, or at least the most popular ones, Cosmos, which raised $17 million, that quickly turned to over $100 million in the 2017 bull market. And they're building what's called bonded proof of stake. The BPoS model is very similar to the Tezos liquid proof of stake model. Users can delegate their atoms to block producers. But in this bonded setup, if the block producer misbehaves and gets penalized, the delegator can also get their stake penalized too. This makes choosing the block producer for delegators a more careful process. Now we will look at Ethereum staking model and how it compares to the most popular staking blockchain, which right now we believe is Tezos. So Ethereum uses Casper FFG, which stands for Casper the Friendly Finality Gadget. And Casper FFG handles block producing by an underlying chain with thousands of like-client validators. In Casper FFG, there is no delegating, so individual staking is enforced if you want to be part of the consensus model and earn block rewards. On Ethereum, we can see that the number of validators, which are the block producers, are in the thousands, with this number expected to rise to the hundreds of thousands when the network matures. Compared to Tezos, where there's only 222 validators, which in their ecosystem, they're the bakers. But there is a very high participation of delegators, but these delegators do not have to run validator software or lock up their capital. They just simply delegate to the block producers. So each validator on Ethereum 2.0 has to deposit 32 Ether in order to start producing and testing blocks. A single user can run more than one validator, but it's important to note that each validator is a separate instance, and the network will not make any connection between the two. And depositing more than 32 ETH into one validator contract gives your validator no advantages over everyone else's. In fact, if you run more than one validator client at any given moment, they can be performing different responsibilities. Since Ethereum validators vote on blocks from different shards, your validators will be spread out, providing consensus, making it impossible to get them to collude together. And we can see why this setup requires a higher amount of capital to be locked and is more decentralized than the current staking systems that support delegated staking. that require no capital lockup. They basically require no capital lockup to earn block rewards. Another centralization we've seen has been around cloud hosting providers. And Ethereum 2.0 discourages this with the offline slashing penalty. One of the drawbacks of staking has been the centralization around the cloud hosting providers, because the validators need to remain online 100% of the time, and many choose to run on a VPS client instead. But Ethereum does have some protocol rules designed to discourage validators from hosting on the cloud. The biggest deterrent is that Ethereum penalizes validators for being offline. And if your validator goes offline at the same time as a big majority of the network goes offline, this penalty increases. So this way, validators are incentivized to host on different networks, so they can minimize the risk of being penalized for being offline when one of these major cloud hosting providers faces, a major network outage or decides to stop hosting node software. So, and also Ethereum 2.0 developers are focusing on light staking clients. These clients will be able to run on mobile devices, for example. This enables a higher participation from everyone, and not just like Linux savvy users will be able to validate on this network. And this brings us to staking services, which is another center of centralization that we're seeing around proof of stake blockchains. And for example, Tezos and Cosmos, these users can delegate their balances to block producers without having to lock up their capital. So the exchanges can easily offer staking services by auto-delegating every deposit while maintaining the user's balance completely liquid. But on Ethereum 2.0, but Ethereum 2.0 does not have a delegation role. So in order to get rewarded for staking, you must deposit into the staking contract where there's a minimum of 18 hours to withdraw from. And this increases depending on the amount of people that are trying to withdraw from the network at any given time. This makes it harder for the exchanges to offer staking services for Ethereum 2.0, because the users that want to stake ETH will not have that ETH liquid. Therefore, they won't be able to trade that ETH on their on the exchange's order books at the same time that they're staking, like in other networks. But we are expected to see different services around this, like being able to sell your stake, ETH 2.0 for a cheaper price to get instant liquidity again. Staking services will have to run a separate validator client for each 32 ETH deposited. This makes it more difficult to manage thousands of instances, and increases the exchange's equipment and maintenance costs, which will be much higher compared to other staking blockchains. Therefore, offering users a lower return that will compete with the dozens of light staking clients that will not carry a service cost. It's just simply the fact that staking Ethereum will carry a higher technology cost will encourage users to not stake with exchanges, because there's just going to be added costs and added fees versus just staking with a light client at your home or through another decentralized solution. All right, so this brings us to our conclusion for the Ethereum 2.0 staking overview. There's still much to learn about Ethereum 2.0, and most of the protocol is being developed, but the staking development is pretty far ahead, so it's unlikely that any of these staking rules will change after this. And we can see why Ethereum 2.0 proof of stake model is not like any other proof of stake blockchain that exists today. Even with Ethereum's thriving ecosystem of more than $200,000 collected in network fees, every day the token economics makes more sense on Ethereum 2.0, because the capital has to be put at risk and locked in order to get block rewards. Unlike other popular staking blockchains that offer delegated staking and provide high inflammatory rewards for empty blocks. The Ethereum 2.0 development is the largest blockchain development since Bitcoin and Ethereum 1.0, and there's simply no comparison that exists today that we can try to compare Ethereum 2.0 to. So thank you for your attention, and to get more research on blockchain topics that matter, please visit us at Multi.io. Multi.io is an upcoming exchange where we focus on listing high quality coins that provide economic value to the blockchain ecosystem. Thank you, and enjoy more of Reimagine 2020.